All right, we are going to take a look at long division with polynomials. One of the things that we can see with polynomials, the operation will mirror the division that previously has been done with integers. So let's look at something like this. Let's say I have 5,245, and I want to divide this by 3. Just some old basic long division. All right, so if I'm working with some of this, what you did in the past was, all right, how many times will 3 go into 5? 1 time. 1 times 3, 3. Then we subtracted. So 5 minus 3 is 2. Brought down the next term and then started that process over again. 3 goes into 22, 7. So 7 times 3 is 21. Subtract 1. Bring down that 4. 3 goes into 14 4 times. 4 times 3, 12. Subtract 2. Bring down that 5. 3 goes into 25. 8 times, 24, and then 1 left over. Right? So 1 would have been that remainder. So let's kind of review here. What do we multiply by? Then we multiplied, subtracted, brought down the next term, started the process over. The final answer here for this problem would be 1,748 and 1/3. So I can write my remainder in a fractional form with that remainder 1 over the divisor. Okay. Now let's kind of look at this in terms of a polynomial. Okay. Let's go 6x squared plus 13x plus 8. And we're going to say divided by 2x plus 1. Division problem, yeah, it looks worse. We've got the x's sitting in there. We've got variables sitting there, plus signs throughout. So definitely a more difficult look than what we used to see with just dividing numbers, do long division. But we're going to follow the same process. All right, so back here, what do we multiply 3 by to get 5? Well, nothing really, but I got close. So I did the 1. So now I'm looking right here at these front two. What do I multiply 2x by to get 6x squared? Well, that would be 3x. Then I'll multiply 3x times 2x, 6x squared. 3x times 1, 3x. I've lined up my like terms. So again, I distributed my 3x times this 2x plus 1. My next step in a long division, kind of refer back here, we did subtraction. 5 minus 3 is 2. Okay. So 6 minus 6 is 0. 13 minus 3 is 10x. Then we'll bring down the next term. Similarly, we brought down the 2 here, brought down the 4, whatever that next value is, and we start over. So, what about 2x? What do I multiply 2x by to get 10x? Well, that would be 5. So we're going to have a plus 5. So now I'm going to distribute my 5 here. 5 times 2x is 10x. 5 times 1 is 5. And then we subtract. 10 minus 10, 0. 8 minus 5 is 3. So 2x won't go into 3. There's no x there. So that becomes my remainder. The way we write our answer. 3x plus 5 plus 3 over 2x plus 1. So there's my quotient. There's my remainder. Remainder 3 over divisor. Remainder was 1 over my divisor. I was dividing by 3. There's where I got the 1/3. Different look. Definitely with those variables sitting in there. Plus signs. We're going to see some minus signs coming up. But same type process. Right? What am I going to multiply by? then I will multiply, then I will subtract. Okay? Let's look at a different one here. Let's go with 6x cubed minus 11x squared plus 11x minus 2. And we're going to divide this guy by 2x minus 3. Okay. Added another term. This one had up to a square. This one's going up to cube. That's okay. It's just one more term. We'll have one more level. Still going to follow that same process. What do I multiply 2x by to get 6x cubed? Well, that would be 3x squared. So then I'll multiply 3x squared times 2x, 6x cubed. 3x squared times negative 3, negative 9x squared. And then I subtract 6 minus 6, 0, negative 11 minus a negative 9, negative 2x squared. That right there, that step right here, this subtraction, and the polynomial long division, that's typically, if we're going to make a mistake, that's normally where it is dealing with those signed numbers. Okay? Over here, they were positive. And a lot easier with positives. 13 minus 3 is 10. Okay? Now I'm looking at negative 11 minus a negative 9. I'm always subtracting. 6 minus 6, 0. Negative 11 minus a negative 9 is negative 2. Let me look at it out here to the side. Negative 11 minus a negative 9. That would be negative 11 plus 9. There's where I'm getting that negative 2. Okay. A little bit tougher. We know how to do the subtraction with the integers, with negative numbers as well as positives, but sometimes we make a little bit more careless errors subtracting negatives than we do positives. That's how I got that negative 2. Okay. Plus 11x. Okay. Drop that next term down, that 11x. Start my process over. 2x times, that would be negative x, or negative 1x, will give me negative 2x squared. So negative x times 2x, negative 2x squared. Negative x times negative 3 plus 3x. And then I go to subtract. Negative 2 minus a negative 2, that would be 0. 11 minus 3, there's my 8x. So again, there's both positive, so usually a little bit easier for us on the subtraction. Bring down my next term, and then I'm back to the start again, or back to the start of my process with this 2x. 2x times 4 would be 8x. So 4 times 2x, 8x. 4 times negative 3 is negative 12. And then again, subtract. 8 minus 8, 0. Negative 2 minus a negative 12, 10. All right, so again, sometimes it's helpful to see it in a linear fashion. I did negative 2 minus a negative 12. That would be negative 2 plus 12. There's where that 10's coming in. Final answer, 3x squared minus x plus 4 plus 10 over 2x minus 3. So there's my remainder 10 over my divisor, the 2x minus 3, giving me that answer there. Now, look at a couple more here. Still dealing with this long division. Oftentimes, we'll see an initial problem, instead of written as a division problem, written as a rational function. So I'll kind of write this one a little bit different here. Let's go 8x cubed minus 6x squared minus 5x plus 3 all over 4x plus 3. So a lot of times we'll see it as a rational function. So I've got a cubic here over this binomial. I'm just going to rewrite it in a division format like we see right here. So 4x plus 3, rewrite this guy. And then I can work my process. Now we might run into that same idea of subtracting negatives here. We'll take care of that and look at that a little slower if that happens. I'm suspecting that because I see negatives sitting here, but let's see. All right. 4x times 2x squared will give me 8x cubed. And then distribute plus 6x squared. Subtract. 8 minus 8 is 0. Negative 6 minus 6 is negative 12x squared. We need to remember for long division, we're subtracting. 8 minus 8, 0. Negative 6 minus 6 is negative 12. Drop my next term or bring down that next term. And then look at that 4x again. So 4x times negative 3x. So that would give me negative 12x squared minus 9x. There's my subtraction again. Negative 12 minus a negative 12, that's going to go to 0. Negative 5 minus a negative 9, that will be 4x. Right? So again, negative 5 minus a negative 9 would be negative 5 plus 9. Going to give me 4. Bring down. Plus 3. So let's see. 4x times 1 would be 4x. Distribute. 1 times 4x plus 3 is 4x plus 3. Subtract 0 for that remainder. So no remainder this time. That's fine. That means this would be my solution to the division problem. I don't have to worry about a plus or minus some remainder. I have got my value right there. That remainder was 0. Let's look at one other in a rational form. Let's go 9x to the 4th plus 12x cubed minus 4x minus 1 all over 3x squared minus 1. Now, it's still a division problem. I know I've got a square there now on the bottom, a 3x squared minus 1 binomial, rather than just a linear one. Still a division problem. I can still set it up in my long division. So to do my long division, I'm going to have a 3x squared minus 1 outside. Inside, a little bit of a different change here, or a different thing we need to add in. I'm going to have 9x to the 4th plus 12x cubed plus 0x squared minus 4x minus 1. So what I've done here is I've added in a placeholder. Okay? I need to account for all of my place values. Now, we've used zeros for placeholders before. Here's a basic example. This number is 405. There's a 0 in the 10 spot. It's just signifying there's 0 tens. It is my placeholder in the values. It's telling me what's in my tens position. So my 0 up here. Hey, what's in my square position? Nothing. It's a placeholder. I didn't have to worry about that before. The two problems I erased, I didn't, but let's look at this one that's still on the board. Cube, square, first power, nothing. I have every place value accounted for in that polynomial. This one, 4th, cube, 1. I'm missing the square, so there's where that placeholder is going in. 4th cube, I need square, 0x squared. There's my power of 1 and 0. If we need a placeholder, we want to put it in because if we have to do some subtraction, remember, we want things to line up with like terms. So let's take a look here. My division process isn't going to change. What do I multiply 3x squared by to get 9x to the 4th? Well, that's another 3x squared. So now I multiply. That would be 9x to the fourth minus 3x squared. So I went over and put my minus 3x squared in the x squared column because that's my like terms I'm looking to subtract. 9 minus 9, 0. 12 minus nothing is 12x cubed. 0 minus a negative 3 is plus 3x squared. So there comes that negative again in the subtraction. 0 minus a negative 3 is a positive 3. Okay. Bring down my next term. 3 times 4x will give me 12x cubed. So 12x cubed minus 4x right there. Again, lining it up with its like term. 12 minus 12 is 0. 3 minus 0 is 3x squared. Negative 4 minus a negative 4. That's going to be 0. It's negative 4 minus a negative 4. Bring down my last term at negative 1. So what do I multiply 3x squared by to get 3x squared? Well, that's 1. Okay. So now I'd have 3x squared minus 1. Subtract 3 minus 3 is 0. Negative 1 minus a negative 1 is 0. So remainder 0 again. That means this is my answer. These last two problems, I didn't have a remainder. Now we're just working division here. But one of the things to note, since we ended up with a 0 remainder, that will come into play later on for you is the fact if your remainder's 0, that means you found a factor. So that would mean 3x squared minus 1 is a factor of that fourth degree polynomial. 4x plus 3 is a factor of that cubic polynomial. Factor just means it goes in evenly. Okay, using some basic numbers, I would say that 4 is a factor of 20 because 4 goes into 20 evenly. 3 is not a factor of 20. Doesn't go into it evenly, but I can divide it. I can divide 20 by 3. It's just not a factor. It's going to have a remainder to it. These two, since the remainder was 0, is a factor. Again, we're just working with the division, long division with polynomials, but that's an interesting thing to note and something you'll see later on because that 0 remainder does tell us a lot more than it's just a remainder of 0.